So, good morning, everyone, and welcome to a brand new lecture. This is the first lecture on motion in one dimension. So, we are basically starting with your actual physics. Up till now, what we were doing was also physics, but more of basic physics. And right now, we are going into the core topics of physics. Now, before going on into motion in one dimension, do you have any idea what do you mean by motion in one dimension? This is something that you have already studied. Remember, your 11th standard is just like your 9th standard. Whatever you studied in 9th standard, same things are going to come in 11th standard, but on a slightly higher level or note, and some extra topics would be added onto that. So motion in one dimension is something that you have already done in your 9th standard. Do you remember it? Motion in one dimension. It may not be in the name may not be same, but you have done this thing before. Do you remember it? Anyone? Yes. What is known as in your 9th standard if it was not motion in one dimension? What was is known as? Tell me. Either you know it or you don't know it. If you don't say anything, that does not solve any purpose, right? So either you know.
Motion in a straight line.
Yes, it was known as motion in a straight line. It was known as motion in a straight line. That is correct. So you have already done this. You are familiar with the terms that I use. We will go through those terms probably once again so that you have a detailed view of what that term means, and we will try to understand whether whatever you have studied is actually correct, or maybe it requires a bit of tweak, should I say. Now, remember this branch of physics, what we are dealing with, and we must know that this branch of physics is known as mechanics. Do we know mechanics? Have you heard about this term mechanics? This is how it is known as mechanics. Do we have you heard this term mechanics?
Sir, it is a study of kinematics, dynamics, and
Yes, mechanics is basically study mechanic, Mechanic is basically the study of objects that are in motion or motion of objects. If you are studying about a particular motion, that will come under the purview of mechanics when you are trying to study motion. Now there are different ways in which you can classify or bifurcate this mechanics. The most popular one is known as kinematics, and the other one is known as dynamics. Some people also bifurcate it as statics and dynamics, but let us not get more into bifurcation what type of mechanics we are going to study. That does not mean, it's just to introduce you to this concept. That is why I'm just giving you in short kinematics and dynamics. Now what do you mean by kinematics and what do you mean by dynamics? Anyone? What are we going to study in kinematics and what are we going to study in dynamics? In kinematics, basically what we are going to study is the motion itself. We are going to study the motion of a particle. In dynamics, what we are going to do, so basically if I say in short, in terms of what terms do you know, in kinematics, where we are going to study only motion, we are going to study terms like displacement. Have you heard about the term displacement? Velocity and acceleration. These three terms displacement, velocity, and acceleration are basically what we will study under the heading of kinematics. Then what are we going to study under the heading of dynamics? Now, when this term dynamic comes, that basically means we are going to study the cause of motion. What are we going to do? We are going to study the cause of motion. In kinematics, we are not concerned with the cause. What is causing this motion? We don't know. We are not concerned. We are only going to study the motion. In dynamics, which is going to come after some time when we are finished with kinematics, we are going to study the cause of this motion. If I say in terms of things that we know, we are going to study something known as F. What is this F? What is this?
Force, sir. Force.
Yes, we are. Whenever we are going to study force, that branch is the branch of dynamics. Whenever we are going to study displacement, velocity, and acceleration, that branch will be known as kinematics. Do we understand this? Do we understand this? Okay. Now, let us concentrate on the branch of kinematics, because dynamics is all related with force, which is going to come after some time. In kinematics, we are going to study motion of this particle. I hope everyone is just noting down in short. Don't have to write the definition of everything, just see what we are going to do. In kinematics, we are going to study what? We are going to study the motion of the particle, right? Now, this motion, we must understand that this motion could be of various types. This motion could be of various type, and which is what we are going to study. Now, how can I bifurcate or classify this motion that I am going to study? And that is how we begin our conversation, or we begin our lecture. Now, this motion can be of what type? This motion can be of how many types?
Sir, 4 types, sir.
Four types. Tell me, what are those types?
Uniform motion,
Uniform motion, okay, and
non-uniform motion,
non-uniform, two. Then good.
um,
Third one. Well done. You have to tell me what you know. Everything is not measured on the criteria of whether it is right or wrong. Things are measured. I measure things on the criteria how much you know. That's it. It's not right or wrong. Uniform motion, yes, this is it is a motion. Non-uniform. What about the other two? You said four. What about the other two? Anyone else would like to try? Tell me what we are going to study. No one would like to give it a try.
rotatory motion. Hello, sir.
Yes, rotatory motion.
Rotatory,
Good. Very good.
oscillatory motion.
Oscillatory motion, four. Anyone else? Anything else? Or only four?
That much only I know, sir.
Okay, well done. Now, this motion can be divided or classified into this type. The first type is known as translational or translatory motion. Translation or simply translatory motion. The second type of motion, which we are going to study after a long time, is known as rotation. So when I say pure translation, it is pure translatory motion. When I say pure rotation, it's pure rotational motion. Rotational motion. Now, can anyone give me an example of pure rotational motion? Let us forget about translation. Can anyone give me an example of pure rotational motion from everyday life? You can see right now a pure rotational motion happening in the room in which you are sitting. If you look up, and you will see pure rotational motion. No one? Translational, rotational. Yes, yes.
Movement of the earth.
Moment of the earth. Okay. You can give a more simpler example that you
Spinning wheel.
spinning of a wheel, the fan that I see on top of your head from the ceiling, that is pure rotational, my dear friends. That is pure rotational. And the fan that I have here also is pure rotational. Spinning of a wheel, pure rotational.
Globe.
Rotation of earth on its own axis is pure rotational. Yes, beta. So, translational, rotational. Now, when I talk about a translational motion, if I have a block moving on a road, flat block, which is a question that we are going to solve many a times, a flat block moving on a road, or a car or a bike moving on a road, the motion of the entire car or the entire bike is pure translation. Do we understand this? I'm not talking about the motion of the wheels of the car. I'm not talking about the motion of the entire car or entire bike as one body. That motion is pure translation. Do we understand this?
Yes, sir.
Translational motion, rotational motion. Then what is the third type? The third type obviously would be a motion which is combined, translational plus rotational. Now, can you give me an example of this? Translational motion as well as rotational motion ka combination. I gave you an example of pure translation. I gave you an example of pure rotation. Can you give me an example of translational plus rotation?
Moment of the car wheel.
Yes. Imagine the wheel of the car or your bike or your cycle. Now that I'm not talking about the motion of the cycle, I'm talking about the motion of the wheel of the cycle. The wheel of the cycle is rotating like this, but at the same time it is also moving forward. That also moving forward, that also moving forward, that also moving forward is translational, and that spinning is rotational. Do you understand this?
Yes, sir.
So it's a combination of translational plus rotation. These two gentlemen are going to come at a later stage. What is going to come now then? Ma? What is going to come now then? These two gentlemen are going to come after a long time. Then what is going to come now? Just now. What? Arey? What are you going to study now? This is way afterwards. At the end of mechanics, literally. What are we going to study now? What we are going to study now is pure translational motion. Do we understand this? What we are going to study now is pure translational motion. Do we understand this? So basically what we are going to study now will be motion of a car, motion of a cycle, bus, bus, vehicle, blocks, the entire block, the entire bus, entire car, entire cycle will move as one body. So we can take them not as objects. This object moving like this is translational motion. This. So instead of imagining this as this body, I can just imagine it as a point. And in most of the cases that we are going to solve the question in translational motion, instead of drawing the shape or looking at the size, we will be drawing them as a point object, because they are having all the points on this body are having same motion. Do we understand this? So instead of drawing their shape, we can just draw them as point. Do we understand this? That is what we are going to study in translational motion. The motion of the entire body as one body that will be moving in a very simple way. Because when it rotates and then moves, the motion may look a bit complicated. So we are now trying to understand the motion in its simplest possible way, and that is your translational motion. Now this translational motion can again, my dear friends, be subdivided. I'm not talking about the division of rotational motion because we will study when we come to that part. This can further be divided into two categories. Now remember, whatever you have studied in 9th standard or previous classes, it's definitely correct. But you may not have studied those points in depth. You might have studied, just touching the surface, you have gone. And if you touch the surface, you do not know how deep is your lake, whether it's a lake or a pond or a river or it's the Atlantic Ocean. So when you're skimming on the surface, you don't know the depth. Probably you have just skimmed on the surface, and gone. And in this class, in 11th standard for JEE, we'll be diving deep into the ocean and trying to measure the depth of the ocean. So every topic we'll be trying to deal in detail, and that is the difference between your 9th standard, which is here, and your 11th standard, which is somewhere there for JEE. That you even can't see because it is out of focus right now. Do we understand this? Yes or no? Translational motion. Now, how can I classify this translational motion? Same thing, you have studied that before, but you now are looking at what's inside this and not going like this. Translational motion. Now I can divide this translational motion into two categories. One is known as rectilinear and the other one is known as curvilinear. Now these two terms may sound a bit awkward, but this is how it is there. What do you mean by rectilinear and what do you mean by curvilinear? That is the next point. Rectilinear, curvilinear. Anyone? What do you mean by rectilinear? What do you mean by curvilinear?
Sir, the body moving in a straight line known as rectilinear. Sir, the body moving in different directions is known as curvilinear.
The first one is definitely bilkul correct. If the body moves in a straight line, this is simply motion in a straight line, my dear friend. Or we can also call this motion as motion in one dimension. Do we understand this? Yes or no? No or yes? Can I have some raised hands from everyone? This is your motion in one dimension. It's a particle or a body, remember, whether it's a car or a bus or a train, we are going to treat it as a particle. When I say it's particle, we are going to treat it as a point, unless and until we talk about the length of that body. Because there will be some question where we'll be talking about the length of the car, length of the train. That is the only way. That is the only question in which we are going to treat them as lamba bodies. Otherwise, we are only going to treat them as what? Particles. Point. Do we understand this? Particle. Point. We are going to treat them as points. Motion in one dimension. The particle or the body is going to move in a straight line. What are the examples of this? Just let's give you an example. If a particle is moving like this, it is motion in a straight line, yes or no? If the particle is moving like this, it is motion in a straight line. If the particle is moving like this, it is motion in a straight line. If the particle is moving like this, it is motion in a straight line. What about a particle moving like this? Is this motion in a straight line?
Yes, sir.
Yes. What about a particle moving like this? Is this motion in a straight line? Yes. All these are motion in a straight line unless and until they turn and change the direction of motion. Now, even if they turn and they come in the same straight line, that is still known as motion in a straight line. Do we understand what I'm saying?
Yes, sir.
So, unless and until they turn and move in some other direction, the motion remains motion in a what?
Straight line.
Straight line. The best example is this, turning and coming back. What is this? The gentleman is the body. I throw it up. Boing, ding. I hope you can see this. I'll bring it on the bigger screen. Rubber, eraser. I throw it up. Tong, comes back. That means it has gone up. Dhar, 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 up till here. You can see it. And then it comes back. Goes up, comes back. Goes up, comes back. Motion in a what?
Straight plane.
This is motion in a straight line. So unless and until what? I change the direction of motion in a different direction, the motion still remains motion in a
Straight line.
straight line. Do we understand this?
Yes, sir.
That is known as rectilinear motion or motion in a straight line or motion in one dimension. That brings me to the next point. What do you mean by the next thing? Curvilinear.
Motion in curves or projectiles.
Only motion in curves.
Or
It cannot.
projectiles.
It cannot be motion like this. Jug 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 jug. Is it not curvilinear?
That's rectilinear, sir.
No, that is not rectilinear. If I just move like this, dug 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 dug, this is rectilinear. If I go like this, dug dug dug, this is not rectilinear now.
This is
Because
projectile, sir.
we are not talking about one portion of the motion. We are talking about the entire motion. The entire motion is not rectilinear now. Do we understand this?
Yes, sir.
Part of that motion is rectilinear. This part, dug 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 dug, is rectilinear. This part, dug 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 dug, is rectilinear, but the entire motion is not rectilinear. So what do you mean by curvilinear? As soon as you hear the term curvilinear, the first thing that comes to your mind that the motion would be in circles or in curves. That may not be completely true, because curvilinear motion can again be further subdivided into two types of motion if you want. The first type of motion is known as motion in a plane, my dear friend. Motion in a plane. A body moving on a plane, which is also known as motion in two dimension, my dear friends. Motion in 2D. What is the example of this motion? The simplest example I can give you is right now what the motion of my pen is. My pen is going like this. Dug 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 dug. This is motion in two dimension because the motion is happening on the plane of the writing board or whatever graphic tablet that I have. Do we understand this? This is motion in two dimension. If I go like this, dhak 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 dhak, this is also motion in two dimension because the particle is moving on a plane. When I say plane, I mean it moves on a surface or it moves on a area. Do we understand this? Motion taking place on the top of this table, dung dung dung, which I am beating right now, is motion in a plane. Motion of an ant, it is moving on the ceiling or on the wall or on the floor. It's motion in two dimension because that motion is happening on a plane. Do we understand this? What is the third one then? Curvilinear motion can be of two types: motion in a plane, or the next one is motion in space. Anything moving in space, it can move like this. Nui, 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 nui. It can move in all the three dimensions of space. That is known as motion in 3D. Motion of a butterfly. It goes anywhere. Motion of a flying insect. Motion of a bird, crow. Motion, your motion when you are moving up or down or going from one classroom to the other classroom and going up and down also. Your motion is also motion in space or motion in 3 dimension. Do we understand this? Everyone is getting? Remember, what we have studied in 9th standard is just a bit of it probably. And we are doing the same thing in some detail in this class. That takes us again to what we are going to study now. Remember, we are in the branch of physics which is known as mechanics. Mechanics, kinematics and dynamics. Dynamics after some time. So right now we are in kinematics. So we are going to study motion. In motion, this motion can be of 3 types: translational, rotational, or combination of motion. In this translational motion also the motion can be of 2 types: rectilinear and curvilinear. In curvilinear again of 2 types: 2D, 3D. What are we going to study in this chapter? What motion are we going to study in this chapter? The first chapter. Which one?
Motion in straight line.
1D and 2D.
Yes, we are going to study motion in a straight line to start with. That means we are going to study whatever is in blue right now: rectilinear motion, or motion in a straight line, or motion in 1 dimension. That is what we are going to study. The other part, curvilinear motion, would be done after we finish your rectilinear motion. So that is a brief introduction, a short introduction of what we are going to study. Because we must understand what are we studying before we study anything. So right now the heading is rectilinear motion or motion in 1 dimension, or motion in a straight line. No matter how you call it, we are referring to the same thing: motion in 1 dimension. Now, so that is an introduction. I hope everyone is there. Okay. Now, to study this motion in 1 dimension, what all, see, whenever we are faced with a problem, whenever we are facing a challenge, we must have arms and ammunitions. When I say arms and ammunition, I do not mean guns and bullets and topes and rocket launchers. What I mean is skill set. What are the hatiyar, arms, ammunition, skills that you need to have to encounter or tackle any problem? Now, once you become engineer, electrical engineers, you will have your knowledge that you have gained in your IIT or NIT or all the good colleges that you are going to study in. That is going to help you face the challenges in life. Now, the challenge here for us is to understand or study motion in 1 dimension or rectilinear motion. Now, to study that rectilinear motion, we must also have some arms and ammunition and skills. You will need some tools to study this motion in 1 dimension. For example, if I have to write, I need this, my pen. But even if I have a pen, I just can't write here on air in space. I need this gentleman to write. So if I have to take a class, I need Wi-Fi connection. I need a laptop in which I can start all this meeting thing. Then I need a camera where you can see me. Then I need this so that I can write. Then I need something that I can write this on. I need tools. Similarly, to study any motion, we need tools. What are the tools? What are the things that we must have with us so that we can study this? What do you think? Remember, things are very simple. Physics is very simple. Physics that we are studying is very simple. The only complicated part is quantum physics, which no one understands. That is why it is complicated. But physics we are going to study is very simple, and we'll do it very simply. And those simple questions will come, and I'll prove that. What are the tools we need to study this? The simplest possible question. What are the things we will require to study motion? Forget about motion in 1D, 2D, any motion that you see, the motion of this fan, the motion of my hands, the motion of a person walking, the motion of a car moving. What all things that we need to study that motion? Tell me. And it has got nothing to do with physics. It is all common sense or common observation. Observation. So we need someone who is going to observe that motion. Yes or no? So the first tool that we need is an observer who is going to observe that motion. Because if no one observes that motion, what will you study? You will have nothing to study. Do you understand this? We need an observer who is going to observe that motion. Now, we can think of observer as an observer. For example, I right now sitting in my room is an observer who is observing lot of things happening. I see this fan running. I see my mate coming and going from here. I am seeing a lot of things. I am the observer. Now, the observer can be a stationary observer like me, or it could be an observer sitting in a bus and that bus is moving, or a train which is moving, or a plane which is moving, or a car which is moving. Stationary observer, it can be a moving observer, it can be someone in the International Space Station and who is looking down at us, and he is looking at some very fascinating things because he also sees us rotating, and the earth is also moving around the sun, so the motion that he sees is very complicated. Anyways, we need an observer. Now we can say observer is an observer, or we can use a very fancy term for an observer. For example, I am the observer right now, and I am sitting on ground and I'm not moving. So whatever I am observing with respect to me, and me is nothing but standing on ground. So I'm observing everything with respect to ground. Do we understand this? The ground becomes my reference frame. Wherever your observer is, that becomes your reference frame. And this reference frame is the second tool. So I am the observer, I am observing the motion, and I am on ground. So I am the observer, and ground is your reference frame. You are imagining everything, studying everything, observing everything with respect to ground. If I am sitting in a moving bus, the bus becomes the bus cannot observe. That is the point that I am putting an observer there. The bus cannot observe on its own. It's a non-living thing. So that's why I have an observer, and that observer is inside a bus. So your bus becomes your reference frame. Do you understand this? Observer, reference frame. Now, whenever you are observing something with respect to a reference frame, if you want to see, you'll have to take some reference. So you have to take some point which you can call as zero. Yes or no? Otherwise, how will you say where? For example, I am the observer, and this is an object that I am observing. Where do I say this point is? Where? Here. I can't say it here like this. No, pointing an arrow like this. That will not make much sense. This rubber is here. This eraser is here. That does not make any sense unless and until I have a zero, a reference point. Yes or no? I must have a reference point so that I can refer to things with respect to that reference point. And so I have this as my reference point. This will become my plus x, this will become my plus y, this will become my plus z, and this becomes my origin. That becomes my reference frame, or that becomes my reference axis. This is my point O. Now if I have any point P here, I can tell you where this point is with respect to what? With respect to my zero here. Now if I change my zero, for example, if I have this reference frame and I shift my 0 to 0 dash or O dash, this is my x dash, this is my y dash, and this is my z dash. Now, the same point P, if I talk about the x coordinates and y coordinates and z coordinates, the same point P will start to look different in terms of x and y. Yes or no? It has not changed its position. The point P is still there. But depending on my O, my first origin was O, my second origin is O dash. Depending on my choice of origin, or I can say depending on the choice of the reference 0 or my reference frame, the same object may look different. Therefore, this reference frame or your origin plays a very important role. In fact, it is the most important thing that you must understand while we are trying to study motion. The most important point is this reference frame. Whenever you are studying a motion, it is always with respect to a reference frame, and this reference frame plays the most important role in studying the motion. This reference frame plays the most important role in studying the motion, because if I change the reference frame, things may start to look different. For example, I gave you this example right on the board. If my origin or my reference frame is O, X, Y, Z, the point P, which is still point P, the coordinates X, Y, and Z coordinates will be different. If I take it to if I shift my 0, if I shift my reference frame, if I change my reference frame, the point P, which is at the same position in space, but its coordinates, its x, y, and z coordinates will start to look different. Similarly, let us take the example of a person sitting in a bus and a person standing on road, and see how the difference comes. For example, this is what I have is a road. This I have a person, let us say person A, and then I have a moving bus. Do not go on my revolutionary drawing. My drawing may not be so good, but the concept is what you have to understand, not the drawing. And then I have this person B. And then I have this person C, which is sitting in the bus. Now, if my reference frame, if my observer is this gentleman, the black gentleman. By black, I don't refer to. I'm just referring to the color of the drawing that I have made and nothing else. If I am the black gentleman, my observer is the black gentleman who is sitting on ground, who is standing on ground, and then I'm observing, the motion of this boy in red. What do I see? I will see that this boy red is moving forward with a velocity v. Yes or no?
Sir.
So for me, this gentleman is moving. But if I change my reference frame and if I shift my observer to this position, if I become B, chilling out in the bus, if I become the observer B, and then I watch the motion of C, same gentleman whose motion A is watching, I will see what? I will see that the gentleman is at rest. The gentleman A sees that the gentleman is moving, C is moving, B sees that C is at rest. C is doing what he is doing. He has not changed anything. But to A, C looks at motion. For B, C looks at rest. Why is there a change of perception? Why is one seeing C moving and the other gentleman sees that C is at rest? Why is that change? Why is the same thing, same motion of C?
Reference frame.
It is because of the change in the reference frame. If you change your reference frame, things may start to look different. It is similar to what we have studied in the previous chapter. And if I go back to the previous chapter, If I go back to the previous chapter and I'll give you the same example that I gave you in the previous chapter. For example, I have, oops, wrong color. Why do I use wrong color? I hate wrong colors. I have three boys standing. Boy A, boy B. And then I give a very simple statement. Boy B is taller than boy A. Yes or no? Is it clear? Is it correct? Boy B is taller than boy A. So I write the statement here. B is taller than A. Then I see another boy, C. But then I look at C. And then I say, oh, wait. B is shorter than C. Now concentrate on things that I have highlighted. Taller, shorter. And I am talking about the same gentleman B. How can B be taller and shorter at the same time? Either he is taller or he is shorter. He cannot be both. But
When we take the reference frame according to A and C, so they are shorter and taller, sir.
because of the reference frame, because of the reference or reference standard or comparison standard, B is looking taller in one case or B is looking shorter in one case. But B is still B. Nothing has changed about B. Why B is looking taller and why is looking shorter? Because I have changed my reference. Yes or no? I have changed my reference. Another example. Mass of a body, let us say A, is 5 kg. This is one statement. Then I write mass of A is 5,000 grams. I again highlight the two things. One is 5 and the other is 5,000. How can A be 5 and 5,000 at the same time? I'm again still referring to the same thing, mass of A. But in one thing I see 5 and other thing I see 5,000. What is the problem? Why has things changed? Does the mass of A change? No, mass of A still remains same. Why have the number in first case it was taller, shorter. Now it is 5 and 5,000. Why it has changed? Because I have changed the unit.
In grams.
Yes, I have changed the unit. Unit are comparison standards. If I change the unit, same thing may start to look a bit different because of change in units. Yes or no? Same thing is happening with A and B and C when they are standing. Same B may look taller or shorter depending on what you are comparing with. Now you compare the same thing with the reference standard and the Paathshala example that I gave, my dear friends. The same gentleman C, he is moving with a velocity V to A, but he is looking at rest to B. Reference frame or reference standard is the term that I use for units. Units are reference or comparison standard. Yes or no? So whatever job units was doing in the first chapter, the same job reference frame is going to do in this chapter. Are we able to understand this? Units were used to compare. Here also we are comparing. We are seeing motion from different sides, from different reference frame. And therefore this reference frame as units, because if I just say mass of A is 5, that will not make sense because we have not told you the unit. Whatever job unit was doing in that chapter, the same job Who is doing now? Who is doing the same job now? The job that was done by Unix in the previous chapter, the same job is done by what now? What?
Meters and kilometers.
The same job, my dear friend, is done by? The same job is now done by? The same job is now done by? Reference frame. So everything that we are going to study depends on your reference frame. Without reference frame, without telling us with respect to which reference frame, nothing makes sense at all. Do we understand this? So, to study a motion, first we need an observer. Second, the observer must be sitting or standing or doing something somewhere. That somewhere becomes your reference frame. You must have an origin, you must have a reference frame, and you have two things. What is the next thing that you need to have? The next tool that you need to have to study motion of a body. The third thing that most of us forget, and if I ask you this question, if I talk about the dimensions of this universe or world that we live in how many dimension of universe? I mean, how many dimensions are there in the universe in which you live? So you can see the dimension right here on your board that I've drawn. How many dimensions does the universe have in which you live right now?
3.
Three. No, my dear friend, it is not three, it is
I
four.
think infinity, sir.
It is 4 dimensions. You live in a 4-dimensional world. The 3 dimension that you see in blue are x, y, and z. Length, breadth, height, or depth, whatever. Length, breadth, depth. You live in a 4-dimensional world. Which is the 4th dimension then? Which is the 4th dimension then? X.
Time, sir.
Time, sir. Without time, nothing makes sense, my dear friends, and therefore you need the third tool, which is known as your timing device. Without time, the 3 dimensions of space will not make any sense. You live in a 4-dimensional world. And how do we imagine that time is a dimension? Let us suppose point A, you are A, point B, your friend is B. You are supposed to meet. Now you are supposed to meet, you tell him, A tells B or B tells A that you come to this place, blah 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 blah. You come to this coffee shop, we'll have a coffee there. So let us assume that this place is C. You have told him, A has told B, come to C. B has told A, come to C. See me, I'll see you there at C. All C, 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 C. Will they meet? I have a friend, a very dear friend. His name is Amit. So I call up Amit. Amit, let's meet. Come to there's a place here. What's the name of the place? There's a resort here. Come to that resort. We'll meet. He said, okay, we'll meet. I'll come there. Will we meet? Hmm? Will we meet? Yes or no? A has told B, come to C. B has told A, come to C. Will they meet? This is yes. This is no. No, my dear friend, they will not meet. Never they will meet. Because both of them has not communicated a very important thing. What is that very important thing? A has told B, come to C. B has told A, come to C. They have not told the most important thing that they have to tell. What they have not told each other. What they have not told each other. Huh? What they have not told each other. They don't know physics, that is why the problem is there. They don't know physics. You know physics, so you must know what is the problem. A has told B, come to C. B has told A, come to C. Will they meet? No, they are not going to meet because they have not said.
Because of time, sir.
Yeah, they have not told at what time you should come, my dear friend. A will come now. He will wait. Where is B? Where is B? Where is B? B does not come. Then he goes, okay, I'll go. B has ditched me. Then after some time, B comes. And he comes to C and says, oh, A is not there. Hey, A, stupid A. He has not come. I'll go back. The problem is not with A and B. The problem is they have not told the next thing, which is the fourth dimension, which is time. You can only meet when you are at the same place, but also at the same time. You get a notice on your mobile phone. Join Astic Sir class for JEE Motion in 1D. Come. Will you be able to attend the class? I give you a link also. Will you be able to attend the class? But one thing is missing in that link. Everything is there. Password is there. Google ID is there. Meet ID is there. Everything is there. One thing is missing. What is that missing thing? Time is not there. You don't know when is the meet going to happen. When is Astic Sir going to be here? I will not sit on this seat forever and broadcast this telecast always so that you can see it anytime. Whenever you come, okay, now I'm free. I'll go and see Astic Sir's lecture. That is not possible. Because, my dear friend, time we don't understand. We do understand. But we don't realize that time is the fourth dimension. Now we understand it. So we need to have a timing device. This is the third tool that we need to have to steady the motion. I have a timing device, and with this timing device, you are going to time things. Time will normally start from 0. Now, whatever happens before 0, this is 0 time. Whatever happens before 0, well, you can't go back in time, because if you go back in time, some fantastic things can happen, catastrophic as well. So before 0, we don't know what has happened. So always time starts from 0 and then moves ahead, right? We don't go negative of 0. Do you understand what I'm saying? So whenever you start a question, you will start the question from time t is equal to 0. Whatever would be given to you will be given as t is equal to 0. Do we understand this? Whatever happens before that, we don't know, because that is the time when we put your time clock on. Whatever happens before that, we don't know, because time now starts. So in every question, you will have a big bang. What happened before Big Bang, we don't know. We can only start after the Big Bang. So for all questions, the questions will start from time t is equal to 0, and then the question will move ahead. Do we understand this? Yes or no? So these are the three things that you must remember. You must have an observer. You must have a reference frame where the observer is, and everything depends on that reference frame. Without the reference frame, life doesn't matter. And then you need a timing device. Without the timing device, even reference frame cannot do anything. We need all these three things. If you have all these three things in your hand, then, my dear friend, you are ready to go ahead. Have we understood this? Yes or no? Well, so that's it for today's class. We have made a Big Bang start with all the Big Bang stuff. Time is beginning and everything is beginning. We have studied, we have understood that we have got 4 dimensions, and we have got a hold of the tools that we need to study.
Sir,
In the
namaste.
next class, we will
Sir.
be moving ahead with the definition. Yes, sir.
Sir, very good morning, sir.
Good
Today
morning, sir.
Jayad's birthday.
Okay. Come on, Jain. Let's celebrate it. Let me just first. Come on, Jain. All of you take care, right?